Hello and welcome to IT Security Labs, and thank you very much for joining me tonight. I'm very excited to come back with yet another machine. Today we have an exciting one. We actually have Wazuh endpoint detection system installed. So we are actually shipping logs from our capture the flag machine to our security onion intrusion detection lab. So this is very exciting. I went to Vulnhub and I downloaded this machine from October 2021 by Machine Boy. I did make a change to it by adding an intrusion detection system agent on it, and in this case I'm using the Wazuh agent, and this Wazuh agent is actually forwarding all the events to Security Onion. So I'm very excited to be doing this today. Otherwise, thank you all for joining. This is my attack and detect system. My name is Howard, and every week at 9 p.m. Central Standard Time, we show up, we find a machine that we need to attack, we attack something, then we try to understand what does the traffic look like on the wire, and that's exactly what this show is about. Today, we're going to enumerate a Linux server. It's not every day that you see people detecting on endpoints, especially Linux-based. It's usually Windows stuff. But today we actually have an agent on the endpoint. We are also sniffing traffic across the network as it moves. And in addition to that, we're going to try to identify services that are running. In this case, we're going to identify that it's running an older version of Tomcat, which is very popular for ethical hackers and people who are learning. We're going to upload a reverse shell to this system. Then we'll do privilege escalation using a custom script. In this case, a backup script that is chmod 777. Very silly, things like that. Then what I'm excited about is what do we see in our security onion intrusion detection system? When we attack a Linux system, what happens? That's really the exciting stuff today. If you're just joining us and this is your first time, my name is Howard, and I've been doing this YouTube channel for a while now. And during that time, I got a few certifications like the OSCP and the CISSP and CCNAs and CCNPs. And I'm a lifelong learner, and I'm glad that you're here because this is what we do to get better every week. And I'm excited that you're joining me. My network looks like this. I have a security onion intrusion detection system here at 192.168.38.10. This is where my Kali Linux is. Today is 192.168.38.86. It changes because it's on DHCP. But I'm sniffing traffic using a layer 3 Unify switch, just in case you want to set up a lab like this. And let's assume our machine is running somewhere down here. This is running in a virtual box. So it's somewhere here. We're getting a copy of everything. Arthur, thanks for joining. We really appreciate you joining tonight. And Pyrus, it's good to see you. So that's what we have today. Without wasting a lot of time here, let's just first verify that our intrusion detection system is working. Then once we verify, we can actually go and start the attack and see what the traffic looks like. If you're brand new to information security, I truly believe this is the best way to learn because you actually get to experiment and see real network traffic in your own lab environment. And when you go to work, you can actually be better and efficient because you play with these things. You know, they say you are what you do all the time. And in this case, if you hack during your free time, you actually become a better ethical hacker. And if you also detect, like I'm doing here, you get better at that. All right, so first, let's run in mmap minus sv minus sc on 192.168.38. It's on 57. So this is our enumeration. I'm just doing the top 1,000 ports here. In fact, I would like to do a -vv so I can see everything in verbose mode. Just in case this thing hangs, I want to see that it's working. All right, off we go. So we're enumerating our system. We're given a system. We're saying, hey, what do you have for us? As ethical hackers, we want to find out what's running on this system. And that's what we're up to right now. And we are in luck today. We only have 2 ports open, port 22 and port 8080. So if you open a browser, in this case I'm using Google Chrome, and you visit port 8080, this is what you see. Tomcat And we also get a version somewhere. Yeah, Tomcat 9.0 right here. In fact, this. So what we can do is we can try to find out, are there any known exploits for this version of Tomcat 9.052? I like to use search exploit first. Let's see what search exploit has. Holy smokes, we have a lot. All right, so we have a lot of noise here from Tomcat. All right, but version 9 is here as well. We have a JSP upload here. We also have another. We have a lot here. Let's see what we can find. Going back here, the one thing that if you haven't attacked Tomcat before, this is one of the easiest things to attack. You see this on Hack the Box. I think there's probably like a proving grounds or try hack me room that is Tomcat. Everybody who is learning ethical hacking, this is like the WordPress of attacks. You do WordPress, you do Tomcat, and you do a few other things that are very obvious. And one thing that you will notice right away is it says for secure access manager app is restricted. Users are defined in this. Okay. We also have a changelog here, which if we didn't know the version, we jump to the changelog, and the changelog file always tells you the version. Today we actually don't have to do that. We also have a host manager here, but I'm going to click on the manager web app link that's right here. And it gives us a username and password. Well, we don't have one yet. But also our changelog does verify that we are actually running this exact version. So if the version is not printed for you on the main page and you run a go buster or bust some directories and you see a changelog file, it always tells you the version. And having a version is always going to be your best bet. So we can always look up what that is talking about here. But there's a popular thing that happens with Tomcat. There's an upload feature that is within Tomcat that if we can sign in, we should be able to use. So how do we sign in here? Admin password. Or we can Google, hey, what is the default Tomcat credentials? I think that's a reasonable thing to do since we actually don't know what the credentials are. And when you Google this, you probably run into something like this. This is a GitHub page that says, hey, these are the known Apache Tomcat credentials from the default credentials GitHub. There are many places where you will see this. So the logical thing is you can brute force using these usernames and passwords. And right now, as you can see, excuse me, it's very easy here to see that it's admin, usually the username, or you have role, or you have Tomcat. You can use Hydra to brute force. You can use, there is a Metasploit module that's out there that you can use to brute force. There is also a tool called Tomcatter that is created just to brute force Tomcat. I really like attacking things, but brute forcing is really my least favorite thing because I mean it's very noisy for one, but also it's just trying a bunch of passwords. So we can actually do that. I tried this tool here. It also works. So you can git clone. It's a Tomcat tool that will also work. I tried by hand with Hydra. I mean, not with Hydra, by just doing Tomcat and some of these passwords like Tomcat, that failed as well. Admin failed. Admin Tomcat failed. Row one, Tomcat. Actually, this one worked. When I was doing it, I put Tomcat and row 1, and that actually worked. This one is the password right here. So pick your tool. I'm not going to waste your time too much just showing you how to brute force with this, but pick any tool that you like from any of the ones that I mentioned, including Metasploit. Tomcat row 1 will give you the password. So it'll be row 1. The most interesting thing to use for brute forcing that I found is burp suite. In this case, when you intercept the request with burp suite, you will actually not see. It's like a basic, it's like an encoded request. But regardless of which tool you use for brute forcing, I really think you'll get the password anyway for this one. So once you get in, the one thing that you see within Tomcat is there's this WAR file that you can deploy here. Well, if you go to your MS of Venom, you can deploy a payload in this format, .war. It's going to be a zipped file. It's like a zipped, but that's what it is. Then we can deploy it. So this is where I would like us to go and actually create one. Let's go to my machines, Vulnhub. Let's go to the directory. All right, I'm going to use MS of Venom here. There's also a lot of other things that you can use. I usually have my notes here that says MSF Venom. And say, hey, how do I create a WAR file? Well, this is what it looks like. And this is part of MS of Venom. This could be, you can find this from, say, Hacktricks or any other of those places. But this will output a file called shell.war. So let's just reuse that. For port, let me use 333, random port number today. Then for IP, 192.168.38.86. Let's verify that. IPA. It's 86. Okay, so we are in business. So we put that IP. MS of Venom is going to generate that. It's going to be called shell.war. Let's generate the payload. All right, so once we generate the payload, we should be able to go here, upload our payload. It should show up somewhere here. You see, we already have shell and rev shell. This shell comes with the machine, by the way. This rev shell, I think I did this one when I was just practicing. But it should be one of these. So let's see how this goes. You might be curious. So since we have already done this and we reached out to the machine, we scanned it, what can we see in our intrusion detection system? Well, that's interesting, right? What did we see? So I'm just going to refresh my alerts section here. And I'm looking in the last 2 hours only. And what you'll notice is these ET scans, these port scans here, these are from Nmap. They were already here earlier, but these ones are all Nmap scans that we can see. This one here is interesting. Even though it's low, if it's coming from our host, in this case, this is our machine. Okay, so this is a spoiler for us, but I hope you understand what it's talking about here. There is a file in user local bin backup.sh that is owned by root that anyone can write to. Please let me know what you think this file can be used for by an attacker in the comments before we get there. This is your intrusion detection system that's telling you, hey, we found an interesting file on your system and you need to fix it. In this case, it's a backup.sh. It's a bash script that is owned by root, but anyone can write to it. Let me know what you think we should do in the comments, because this is the significance of the having host-based intrusion detection system. So my Wazuh agent captured this. Let me know what you think, please, in the comments. Otherwise, let's go ahead and see. Okay, so we have my WAR file that has been created here, show.war. So let me move that one to /home downloads. Okay. BT says the file can be abused to get root. I want to see here what everybody can say, because that's an interesting one. Our intrusion detection system is actually telling us. So it kind of spoiled the machine for us. But hey, this is what intrusion detection systems do, right? They can actually audit a system. So that's a giveaway for us. All right, I went back here. I think I put it in my downloads. Here's my show.war. Open it. Deploy. So if you ever see a Tomcat server, this is what you do with it. And this is the easiest attack that you can ever have. So now we have a show.war here. All right, so all we need to do is start our listener. So let me start my listener here, netcat -lv and p on our port. I think it was 33333, like that. Okay, so we are listening. Going back here, here's our shell. It started, so I will just click on the link. I never know where to click when I'm here. It's almost like a joke. I click on the link. Sometimes I come back and I'm like, it didn't work. Where do I click? Okay, let's give it a moment. So we are listening on port 333, because I believe that's what we use MSF Venom for, right here. All right. Thank you all for the feedback. Yes, we're going to use that for our privilege escalation. Now I'm curious, why in the world is this thing not triggering? It's probably because I clicked on the wrong place. All right, let me refresh this page. This actually happens where you click and it doesn't actually, it might take a while. George said I had an error at the top. What was the error? Okay, so shell.war already exists. What are you talking about? I didn't think I had one. Oh, there was already one that was named shell.war. I'm so silly. Let me regenerate my payload. I didn't put that one. That was not mine. That was that actually came with the machine. So let's. I still want to keep my. So I'll name mine shell 123. Okay. I still want to keep my port 333. Yeah, the file already exists on the machine, unfortunately. So I'm generating another one, then we can put it. So my upload actually didn't succeed. Ha! All right. So let's give Tomcat a break here. And generate another one. All right, so while my shell, no, actually it just did. /home. I'll put it in my downloads here. I'm going to put my 123 shell.war. This one. This time it should actually deploy. Okay. Finally, we have a different one. Okay. Now, let's listen. 333. Click on that. That looks interesting. All right, we're in business. So we got our reverse shell. Where am I? I'm in as Tomcat, which Python. I have no Python. So which Python 3? All right, so we got Python 3. Let's make this shell a little user friendly, okay? And for that, I already have, I can type this, but I prefer to put my brain cells somewhere else. So in this case, if I could go back here to my reverse shell, I actually have a Python 3 stabilizer. I call them stabilizers. I don't know what they're called. Okay. Then let me export term. This is just to make sure that the terminal is usable. You can still run commands there, but you notice right away that we have a semi-usable terminal. We're in as Tomcat and ID. Which groups do we belong to? Nada. Usually I'm looking for a Docker group or something interesting. Sudoers group. In this case, nothing. Okay, cd/home. Who do we have here? All right. You will not see this user when you are using a regular machine. I created this user so I can add my Wazuh agent in my monitoring stuff earlier. You only see this one. So let's go with the one that you see. So if you do an ls here, ls minus la, what's happening here? Every time you see notes, that's always interesting. We also have a .ssh here, which is fascinating because every time you see a .ssh for a user with these permissions here, you're in business, because that means that we're going to go from Tomcat to the Thales user by stealing the SSH key from here. That's what we're going to do. I hope we should do that. You know what? Maybe not. Now that I know the file that we found earlier from my intrusion detection, maybe we don't even need to do that. Let's see what's in the notes. I prepared a backup script for you. The script is in your directory. Good luck. Okay, so we know about this script from our intrusion detection system, right? So there are two ways we can go about this right here. And really, it's our choice. This user's SSH directory can be read and written by anybody, which is a terrible thing. That means that we can put an SSH key here and SSH is this user, thereby doing a lateral movement. But now I'm not too excited about that when I know that there's another file that the root user can write to. And all I need to check is verify what are the permissions for this file here in this location. Are they really what I saw earlier? And if they are, then this is just game over. All right. I guess anybody and their friends and family relatives can write to this file. Take notes here. If you are a system administrator, this is an unfortunate thing to do. I wouldn't encourage you to do it. What they did is chmod 7777 because they were lazy on that file, because somehow they wanted to just access it. And we're getting excited because I guess you have to do lateral movement. I'm just going to go and write to that file because I have read, write, execute to that file as Tomcat. So let's go to payloads, all things here, and find us a reverse shell to echo into that location. So I'm just Googling payloads, all things, and then I'll put it up here for you. It's just a matter of choice now. Let's see, can we do a bash TCP? I always do bash TCP almost every time. Also, by the way, there's a reverse shell generator here that we can use. I'm glad they added it here. We have Python 3, so we can also use Python. Let me find something interesting. We can do a metapredator. All right. Let's see. Bash TCP. Let's go the classic one. No, I just did this one last time I did a Linux machine. I don't want that one. Too bad that we have Python 3. I know there's a Python 3 one that I have in my notes. I had to customize it. But for now, let's use this one instead. Let's create it from here. So it's our IP is going to be 38.80.86. Let's leave port on 555. We'll capture using netcat. And I would like a reverse shell on Linux. Let's use this one. I think that should work. Or we can use netcat. But before I use netcat, let me verify. We do have netcat. Okay. So it's just a matter of deciding here which one do I want. Do I just want to do something simple, something interesting like that? I like this one better. If it doesn't work, don't can me. I'm experimenting. I like this one better. So let's echo. No, first of all, let's go there. Bin search backup. All right. So we only have one. Let's echo our command in there. Let's copy that. Output quotes. No. On this whole thing here. I'm experimenting because I don't think I've ever used this one in a live stream before. And we should be able to use either one. And I'm using two brackets here because I want to append to the end of backup.sh tail.sh. I see it right here. Oh, by the way, I already had one on 888. That looks identical. Or maybe not. But I'm listening on 555. So next, I will probably just need to do a listener on 555. But how do I know that this thing is going to fire? How do I know that? Is this running on a schedule? So we don't have anything in our cron tab as far as this thing is concerned. So, of course, it needs to be in the root user's cron tab for it to run as root. So this cron tab that we're looking for here is Tomcat's cron tab. It will not have that. So let me just choose nano for now, then get out of there. All right, there's another tool that you can use to see if you can listen to the cron jobs running. Since I'm just listening right now, I think it's pspy 64. I don't think I have pspy 64 here. I don't. Okay, so we can get pspy64 from our Kali Linux. Every time you see a script, chances are, especially if it's a backup script, someone is running it on a schedule, because people don't like to run backup scripts by hand. So let me see if I have pspy here so we can run it. I hope I didn't get the name wrong. Come on, my Kali doesn't have pspy64? That is ridiculous. Okay, so we can find pspy64 from GitHub, like right here. This allows us to snoop on processes and see what's happening in the background. And pspy64, if you can transport it to your victim, you do these things called cron job watching. You can see cron jobs for everybody on the system, even though you don't own them. That's why we want pspy. And this is how it runs. For now, I'm still listening on 555. So that means that time to set up pspy here. Example from Hack the Box. Well, where's my pspy? So they do have a Go version of that app. I don't like this GitHub page here. I just want the pspy64 binary, so I'll look for that one up. GitHub. And this is what you find. No, that. Okay, so I'm going to do a download for this. Is it a 64 or 32-bit version of my machine? I'm going to go with this one. So here's my pspy64. All right. On 80. I hope my shell isn't. Okay. All right. So first of all, I knew this was going to happen, right? As you can see here, my reverse shell actually finally worked on port 555, which is the one that I put in there. So what this means is I probably got root in there. User bin backup.sh line 35 command not found. I probably messed up with backup.sh here on line 35. Okay, let's get pspy to this machine, and then let's watch it run as well. See. Whatever I echoed in there, it didn't like it. Okay, so it doesn't like this line here for whatever reason. I thought it was oh, it has CMD here. It should be bin bash. What was I doing there? Whatever this thing is talking about here, I think it's not correct. It is CMD. It should be bin bash. Okay, that's why it didn't work. But that's okay. Now I just want to get pspy here so I can show you, because I think that's a very interesting thing too for us to snoop on processes. So let's go to the temp, because that's where you usually put it. Then we do a wget http 192.168.38.86 pspy 64. All right, then you get it in here, chmod plus x pspy 64. All right, pspy 64 is now executable. So this allows us to snoop on the processes. So if you find a script and you are curious, does it run as root on a cron job or not, run pspy 64. Okay, but now the problem that I have is I believe my last line is actually wrong. So what I'm going to do is I'm going to replace everything in that file, because it's a backup script that I can write. So I'm just going to wipe everything and just put another one. In this case, because I don't think nano actually works in there. So I'll first go and change my backup script, then come back to the temp directory and look at pspy 64, okay? That should actually work. And everything that we're doing right now should be documented by our intrusion detection system. So if you go to Kibana, we should be able to see that we moved pspy, we made this an executable file, and things like that. Now let's go back to our file. cd/home. This is where we found that we have an executable with this name here. Okay, so I'm going to replace this with just a regular file here. Let's copy that again. I actually don't need the backup functionality. I just need there to be my file. All right. So what I'm doing here, I'm saying, hey, can we just go in there, replace the entire thing, and just put port 8088? That's all I want at the end of that file. Because I think the first one that I did was wrong. Then let me run my pspy here and listen on port 8088. All right, my listener is ready. Run pspy. So we should be able to see the cron job running in the background from this process snooping tool that we're using. And then, yeah, I ended up not replacing the file. I'm hoping it should execute 8088, but I'm snooping right now. Oh, there we go. This is what it looks like when you're snooping with pspy. The only time you do this, or one of the few times, is you get on a system and you're like, I have no idea what it's running. And I'm just trying to see what's happening with the system. This is usually in real time. What do you think this is? I know what this is because I put it here. Let me know in the comments, what do you think this is? The var or sec agent that's sending data somewhere. Okay, that was us. So we're still listening here. I think it's like every 2 minutes or something like that. So while it's waiting for the cron job to run, I'd like to go back to our security onion intrusion detection system. And let me know what you think that thing is. Yeah, BT says that's the Wazuh agent. Yes, that's exactly what it is. It's called OSEC agent on the system. All right, let's look at what happened here when we were doing things, because this is also very interesting. Listen, status post netcat changed, new port opened and closed. What in the world was this? Let's find out. This is what distinguishes you from those people who are just playing CTF from Vulnhub and hack the box, to people who are actually doing that and actually knowing what they're doing. Like, okay, so a port was opened. Well, we kind of know what happened with the port being opened, right? So let's see here. Let's start listening port. That's interesting. This is for the... Let me know what you think. This is seeing a port that was opened by a Java agent on the system. Let's look at this one here. This must be from our Tomcat agent somehow. And I was trying to pin it to the port that we opened. That's interesting stuff. To be honest, I don't know what I'm looking at here. And it's messing with me because I'm like, what was that? I know we did have a .war file that we uploaded, but I was expecting the exact port that we had for the agent. The rule that matched was bad word matching. Okay. That's very interesting stuff. So when you go and mess with a Tomcat server in the opening ports, this is what you see. Okay. I don't think this is our reverse shell port yet. Let's go back to our alerts. We should be able to see something else. And alerts. So this one we saw earlier. This one also we saw earlier, but I don't know if we saw... Yeah, this one we saw earlier. This is the one that talks about the file that is out there. But here's an insecure connection attempt. I'm pretty sure this is nmap to our machine on the agent name and the IP address from our Wazuh agent, and a random high number port. This is an indicator that it's a port scanner or like a Nessus agent scanner or something like that. So at least now we know. All right. Let's go back and check if our reverse shell came back. All right, it actually did. So on port 888, it came back, and if I say, who am I? We are root. Let's stabilize this into Python. We know we have Python 3. And we do that. Let's gain some persistence by creating a user. I'm doing this to try to upset the intrusion detection system, because the moment I start adding a user, it should freak out saying, hey, somebody added a user. So I'm hoping that will happen. Let's use like Labs 2018 as a password. That's when I started the channel. Yes, that's correct. All right. This channel used to be called Lahi Labs, by the way. Then I changed it. So we found the flag, we added a user. Haircut sudo. Okay, now I forgot how to create to add a user to the correct group here. I just wanted to add my user to the sudoers group, but anyway, I'll find out how to do that. cat/etc pass wd. An intrusion detection system should also not like this. It should also not like this, because I'm touching the most important files on a Linux system. All this because I'm hoping an intrusion detection system will be like, yo, somebody was doing this. But since I'm doing it as root, I'm not sure if it will even trigger for root. That's why I wanted this to do as file user. Let's do something like this. All right. This user is not a sudoer. Good. That user that we just tried is going to be reported. This is my lab password. So if you're like, hey, we just saw your password, you don't have to worry. This is my lab password. You can't actually use it for anything else in my real life. So if this is going to be reported, are we going to see this in our intrusion detection system? If we don't see this in our intrusion detection system, this is kind of useless, right? Because what kind of reporting is it if it doesn't actually end somewhere? So I'm really messing with the system here to make sure that we see things. But we did get root on our system. Now it's time to really verify our detection. So we don't need that one anymore. Oh, by the way, to come full circle, our pspy should have been able to figure out when we ran right here. We're running the script on a schedule. This is what I wanted to show you with pspy. And as you can see, we ran all these commands here. We even ran this one. This is the one that gave us a reverse shell. So you can snoop on the system using pspy. All right. So we're done with the attacking stuff. Is it fun? Yes. Is it helpful? Obviously. But what are we if we just attack a bunch of machines from Vulnhub and we have no clue what that did to the client's network? Some of you are going to show up to a client's network and you're going to run Hydra, or you're going to run GoBuster, or any of these tools that we use for CTF. Wouldn't it be nice if you knew which bells it will ring if they have host-based intrusion detection system? Wouldn't it be nice? Wouldn't that make you look successful? Like a very, normal person who knows what they're doing. If you knew, like, hey, if I run sudo and it fails, guess what happens? It's classified as low, but it's an indicator of compromise. So let's drill down into this one. You can guess what happened here. This was me trying to switch the user on the system and try to be sudo. And look what happened. It talks in plain English. An administrator or an analyst looking at this, they know someone tried to switch to user root from this user here and it failed. This is not a problem because it's low, maybe it's the user didn't know. So it happens once, that's fine. If it happens a couple of times, it's an indicator of compromise. If it happens after you have seen reverse shells being deployed, now that's exciting stuff. So right here, this was me typing sudo su on the system. It failed, and it told me, I'm going to report you to the administrator. And we come back to our intrusion detection system. Sure enough, this thing is talking. You try to do this. So it actually has the command too, right? Yeah, the switch user right here. So this is host-based intrusion detection system. This is not like our network. This is the host telling us, hey, I saw this stuff. You got to go and check it out. What else can the host see? I didn't do lateral movement. Successfully changed user ID. What user did we change a user ID? We created a new user. So I'm like, this thing is either lying or it's reporting incorrectly. Okay, for this user here, we're switching user. We're actually not changing a user ID. So the command that we ran was switch user. Okay, so apparently that switch user command really screams a lot of things to people when they have a Wazuh agent installed. So if you are doing a pen test for a client and you're trying to switch a user and it fails, as you can see here, there's a few indicators that just pop up, including what I just showed you here. Okay, when you create a backdoor user, this one is actually a medium vulnerability in this case. A new user was added to the system. New group added to the system. When in Linux, when you create a new user, a group for that user with an identical name is added. So you get these two here. And I'm pretty sure this one is for our hacker user that we created. This is a backdoor account that I was hoping to add to my sudoers if I could remember the command. Here's the user ID 1002, and the user was a hacker. So what does this tell us? This is beyond the CTFs. I should name my series Beyond Capture the Flag. This is what happens in the real world if you go and you attack a bunch of machines there. Now we actually, we added a user to create a backdoor. The owners of the system know. Imagine if you are like administering systems at a network in a company. The only few times that you add a new user is if you have a new application that needs a special application user to be created, or if you have a new employee. So every time a new user is added to a critical server in your system, and you are the head of IT, the head of cybersecurity, the SAR, whatever they call you, you'll be like, I want to know. A new user that is unique is added to my systems. I want to know. So I would probably bump this alert from a medium to a high. It doesn't matter. Even if the new person was added today, let the alert fire to prove to us that it still fires. A hacker in this case was added with the user ID of 1002. The 1002 ID shows us that this is a regular user. This is not a system user, because a system user is 1000. It's actually 999 and below. Those are like system accounts that are created by applications. If it's above 1000, that's a regular user that will probably have a home directory that can sign in. So this, my friend, is a problem. Especially it tells us, hey, by the way, the person is a home directory and they can use bin bash to sign in. So this is a problem, and thanks to our Wazuh agent, we can see that. What else can we see? Information from user was changed. Yeah, no, that's fine. Okay, let me show you something else that happened here. Let's see. In addition to just monitoring in real time, this agent here will actually also show you very interesting things. Like these benchmarks here. These were configured earlier when I installed the agent the first time, and the agent is very easy to set up, by the way. it will tell you like, hey, by the way, here's all what's wrong with your system, including, I think that file that we had there that we could write to, it's also listed here. All these things here we need to look at. For example, ensure minimum days between password changes is 7 or more. This is what it did. It's like an audit tool that it runs with the Wazuh agent and tells you, hey, this is kind of interesting. You actually need to look into these things. This system has a lot of things. Not everything here is interesting. Like ensure DHCP server is not enabled. Sometimes we don't care. We just want DHCP to be enabled. But I did see earlier ensure SSH user environment is disabled. With SSH for this system, you can actually SSH after you create a backup user, like what I did earlier, which is a problem. We have a banner that is configured. Sometimes you do want that, so that's not a problem. Let's keep looking. Ensure inactive password lock is 30 days or less. So if a user is inactive, and I don't know what these ones are, like these ones. But if you are hardening a Linux system, having a Wazuh agent on it, and you spending time like looking at it, let's say this is the system that was running a website for your employer, and the website is how you make money, I'll probably take all these seriously and go through them and audit the system. Because if, say, you have PCI stuff here, chances are anything that this thing is going to be complaining about is going to show up from the PCI audit that you do anyway. But we have a lot of things that this Wazuh agent and the CIS benchmark thinks is incorrect. I do not have a full Wazuh agent interface, but if you really want, you can actually install a Wazuh server. Then the agent will actually do like a PCI audit or some, I don't know if it is a HIPAA audit, but I know it does have a PCI audit because I've seen it before. So there is more stuff that we can see. Everything that we have spoken so far is from the host, what we saw happening on the host. Well, what happened when we got a reverse shell? We didn't get an alert here, but sure we did get a reverse shell. So we can find out about that right here, like our port 8088 for destination port of 888. It's in the weird here for Zeek. So Zeek sees everything. Zeek is our Zeek does not alert as much. If you want Zeek alerts, you can go to the Elasticsearch. They actually have some rules that will show you how you can create them there. But Zeek tells you, hey, I saw port 888 coming from this IP address to this IP address, which is our host, Kali Linux, in the victim. It was a connection event. And let's see if this was a success. Usually it should have a flag that tells us, okay, so the connection state for this one was a rejected. Please let me know in the comments why we see so many entries for port 888. In fact, we see 15. Why did we have 15 entries for destination port of 888? And I'm pretty sure that if I classify those, a bunch of them are rejected. Why? Why would we see more of those? I think if you can answer those questions, that will even make more sense. Well, we actually have 95. And I know why, and I'm hoping you can contribute in the comments here. We have a slowdown. Why do we have so many? Why do we have 95? You will notice that they're coming from the same source IP, this is our victim, going to my Kali, and they show up all the time. And if I classified this traffic here, a bunch of them are rejections. A few of them succeeded. Why do we have this many? The source port is going to always be some random number because this is the client. But why? Why is this happening? I'd like to know what you think, because I think the moment we know, it'll be something else that we can add to our bucket list of things that we've learned today. Think about what the backup script was doing and how it was being exploited to get root. It was 888 gave us root. All right. In addition to that, while you are responding in the comments, my very first one was on port 3333. This one is not going to have as many entries. We actually have 3, because I tried 3 times, and 3 times only. So source was 192.168.38.57. That was my victim. I uploaded this shell. This was the .war file. I wonder if it will tell us. No, this is just a bro connection event that we saw. We know this was my .war file, and that .war file, .war, was coming from our victim going to my Kali Linux on port 333. This was not on a scheduled task. So the answer that I was looking for, why we had so many destination port of 8888, is because there's a cron job that's running on my victim on the backup.sh file. And that cron job, every time it runs, it tries to reach back to my Kali on port 8888. Yeah, thanks BT. I see BT says it's the cron job. It is the cron job. That cron job, that's exactly. So if I keep talking here and I come back here after, say, 5 minutes, this number will be up because the cron job keeps doing its work in the background. And really, this is why we do these things, right? Because these things add up. They make sense. A cron job, it runs, this number goes up. Cron job runs, this number goes up. So if an attacker is persistent and sometimes they're failing, you can actually track them the way we're doing here, which is you can see what they're doing. You are no longer a CTF player. You are now a cybersecurity person who is actually involved in figuring out what's actually happening, instead of just like, hey, I solved Vulnhub machines, which is great, but this is even better. All right, so for port 333, we saw that as well. I'm curious, those .war files, remember I did a shell.war that failed? Whatever happened to them? Can I find them? I wouldn't do this at work. By the way, I'm only doing this in my lab environment because I have very few files. I can afford to use wildcards. If I were you and I'm setting up an intrusion detection system for a company, I will lock down and make sure that people don't run wildcards the way I'm doing here, because this could be searching through 10 million events and this will lock your Elasticsearch database. All right, so we have a star.war. We're looking for that war file. Going to 8080. Okay, what happened here? Well, first, who done it is Zeek. Zeek sees everything. So the URI that we went was an upload. Look, here's the session ID when we uploaded something. I'm hoping that I can see the name of the files. So the username was Tomcat. The application was zip. Okay, so we can actually see the file. That's interesting. So where did the .war come from? Wait a second. I'm blind. I'm really blind. Here it is. Show 123.war. This is the one that worked for us. So if you were tracking down like an upload from a person, here's the name of shell 123. So that means that we should be able to identify the next one. Okay. It's the same shell 123. We clicked on that file twice, and here it is right here. I have to remind you, this is what we saw on the network, on the wire. This now no longer has anything to do with the Wazuh agent or host-based intrusion. This is network-based intrusion detection system. We can only see this because it was HTTP traffic. It was not HTTPS, and we're not decrypting any traffic. If it's HTTPS, you have to decrypt it, or otherwise all this is going to be gibberish. That's another thing to note here as well. All right, so on the manager, what did we do this time? Okay, this is the shell that failed. The shell.war. So we can identify specific Tomcat files. So if this Tomcat server was very important to us and we're like, okay, every time somebody uploads a plugin or whatever that upload thing was doing, we'd like to know, even if it's an internal person. We can monitor for this extension here when it's uploaded to this URL or URI, and when business, we have an alert, it will fire and we'll be like, hey guys, so you know we're going to be making some changes, expect some alerts, great. Or you can suppress the alerts ahead of time, then just monitor for this stuff here. In this case, this extension being uploaded to your system. The best way is though is just look it up. Don't allow everybody and their friends to upload stuff to your server. Change your passwords. Instead of having the default passwords that I could find from, where was that? The internet. Change your password to something more complicated. Also add your intrusion detection system. You can create custom rules. In this case, if you use the Elastic SIEM solution, which is what Security Onion is based on, you can actually create a rule on the fly and say, if you see this extension, I'd like that to be a thing. Or if you want to use Security Onion, just go and create a rule in suricata, and suricata will actually fire, which is going to be the greatest thing here. Right, I think I've spoken for a long time and I've looked for interesting stuff. Please let me know in the comments if there's anything that you'd like me to look at. Otherwise, I think this was a very fun machine. And to be honest, I will never attack a Vulnhub machine the same way like I did before. I'll always add a Wazuh agent before I attack a machine. And if the machine actually allows me, I'll make sure that I can observe it, because some machines are very unstable from Vulnhub. But if you can add a Wazuh agent, forward all the logs to Security Onion, try to understand how the logs communicate and which of them generate alerts or trigger by default, then of course get better and create your own rules if you can. But for now, I think this was very interesting stuff here, just looking at it. Let me know in the comments if there's something that you would like me to look at. Otherwise, I'll just wait for a couple minutes here, see what people think. And while I wait, I'll look at these. Who changed the password? Okay, so we created a new user and it thinks we changed the password, but both you and I, we know we never changed any passwords here. This was the new user that we just created right now. So do we tune this alert to tell us that it's a new user, or do we leave it the way it is? I'm not sure. Yeah, I'm not sure, but this alert here is kind of misleading because it's telling us the password is changed. Wow, we didn't change the password. We created a new user. So it's helpful at the same time, maybe not. Oh, look at this one. Cron tab opened for editing. I opened cron tab that belonged to the Tomcat user. And by doing that, I got reported by the Wazuh agent. Yo, you open cron tab, we're going to talk about it. The good thing is it's a low alert, but it did report like, hey, this person is messing with cron tab. I truly think this is it's kind of funny because it's just a file that I owned. I didn't open the root cron tab file. I opened my own cron tab. So for the Tomcat user. So, no, this is not, Ray is asking, is this a daily stream? No, this is a weekly stream. It only happens on Sundays at 9 p.m. What in the world? Let me know in the comments. I truly think this is kind of ridiculous. You touch a cron tab file, you get reported. If a user edits their own cron tab file, I don't think it's a big deal. If they use sudo privileges to edit the root cron tab file, that is a problem. But I'm not sure. Would you suppress this alert here? Because Tomcat was editing their own cron tab file. In a big enterprise, you get a ton of alerts because people do this all day long. So I'm not sure if that one is a helpful one or not. Information from user was changed. What information? Okay, we created a user. So I guess, yeah, we did change the information for a non-existing user. So as you can see, I hope you can see, like right now as I'm talking, I'm like thinking about it. I'm like, wow, the user didn't exist. But if somebody modified an existing user, I would like to know. But if somebody added a new user, I'll probably already have an alert for it. So all these alerts here that got fired from just creating a single user, a bunch of low and medium alerts got created, including this one. Okay, who was using SSH to authenticate? It's a low. Okay, this is when I SSH into my security onion with this user here. All right, I think we are good. This is really fun stuff. So if you like this, if you like to be able to attack a machine from Vulnhub, learn how attackers do things, but also be aware of how much noise you generate, please join me every Sunday at 9 p.m. Central Standard Time. Subscribe, like, and hit that bell icon. I think you get notified in your email every time I go online. Otherwise, this is really fun stuff, and this is how we grow. And I hope you learned something today. Otherwise, I will see you next Sunday at 9 p.m. Central Standard Time. Thank you.